all. Like they get buried. Alrighty, let me get this all going on the right thing. Alrighty, we are starting up the rock cycle. And I know some of my students are like, rocks are so boring. Yeah, they can be. They're rocks. But some rocks are kind of cool. And yeah, diamonds are sort of cool. And I have, well, you can make synthetic diamonds. In fact, when you die, you can have your ashes turned into one. It's very expensive. We probably did. We probably did. If not in this class, it was in 5th period, because in that class at one point in time, we were talking about different societies that were so in such straight situations that they had to resort to eating babies. And then they started talking about making clothing out of baby skin. And I was like, what is wrong with you guys mentally? Like the conversation went way over here.
That was,
I want to say it was 5th period when they were talking about it. I was like, that is just so messed up on so many different levels.
That didn't actually happen. It was something.
I bet you wrapping babies in bacon.
That, okay, stop it. That's disgusting.
Baby poppers.
Nasty. All right, so we are going to start the rock cycle. I have, oh God, Kaden, stop. I'm recording right now. That is horrible. All right, so we're going to introduce the rock cycle, and we're going to go into gems and minerals tomorrow. I started building, I'm going to do, next week, we'll do igneous rocks, the ones from inside the earth. We'll do metamorphic. Actually, we might do igneous and then sedimentary and then metamorphic. I don't know which order I'm going to do them in yet. But those are the 3 types of rocks. On this planet, probably not, but maybe like in spatial, probably yes. Or at least some chemical combination that doesn't happen here.
That would be kind of
normally. So, I started building the igneous notes yesterday. And it got up to 45 slides for one day, and that's impossible. So what I may do is just do a brief overview on what an igneous rock is, what a metamorphic and what a sedimentary is, and maybe a few examples. And then when we do plate tectonics after Thanksgiving, we'll get more in depth in it, because I can't make you guys do 40-something slides. Even if I give you most of the notes on paper, that's insane. It's too much.
Yeah.
It just is. It's. I don't think it's physically possible. So I get to tweak those this weekend. But then it'll be a review on Thursday, and we'll test on Friday, and then it's Thanksgiving, and you won't have to deal with my class at all over Thanksgiving break. Unless if you miss this. Well, I told you guys I was going to try to shut it off and then start a new unit after Thanksgiving, which will be plate tectonics. And so for the opener, original earth rocks, the very oldest rocks. How are they made? Or what were they made from? Okay, from molten earth. Okay, now if it's inside the earth, it's magma. Okay, if it comes up through the volcano, then it's lava. Okay, but it's still molten earth. What happened to those rocks? What happened to the original rocks?
They sat there for a really long time.
Did they stay their original consistency? Did they change? Did they?
Yes, they changed.
So.
Letters are built on top of it.
Okay, that's true statement. I've heard a few true statements.
They crystallize.
Okay, now the original ones, yes, like these, the ones with all the pretty colors and the big crystals, these are old. Okay, now I'm not saying they're from the beginning of time old. Okay, but your igneous rocks, these ones have lots of pretty colors. And I know they can't see it, the chunk of amethyst that I'm holding. Sometimes they have very large crystals and they have very pretty colors. These form over very, very, very long periods of time. This actually was formed from magma, not lava. Whereas the little geodes that I have, which will pop one eventually, they have crystals inside too, but these form very quickly from lava that cools off. So they're still both igneous. They're both igneous, but they look different.
So obsidian would be.
Obsidian is a quick cooling igneous rock. Yes, looks like glass. Yes, it does.
They make really good.
They do. It's extremely sharp. American Indians used to use it for arrowheads and spear points, but they're also very, very fragile. They break very easily. So, obsidian. It's glass essentially. So we have all different things that make up our rocks. Like I said, there's three major branches. It could be sediment that's compacted, which I think is what you say, that's a sedimentary rock. It could be one that's from the bowels of the earth, an igneous rock. This is also igneous. This is my daughter's big geode. And on the outside, it looks like, y'all, one of my chemistry kids actually asked me if this was a real dragon's egg. And I looked at him and I went, yes, I'm going to hatch a dragon and I'm going to be a billionaire. I was like, you really think it's a dragon egg? I'm serious. Okay, but on the inside, there's dark crystals. And then it's got this red that runs through it. So I know that it is called ferruginous druzzy quartz. I actually had to test it to see if it was quartz or not. Had to use hydrochloric acid. And I know you guys can't see these all. Maybe I'll take pictures of them and upload them into Canvas because they can't see my rocks up here. Hopefully this will not take us super long. I did put some images on the picture or on your skeleton thingy for you so you don't have to draw everything out. I put the rock cycle down on the bottom. You should be able to read those words. But there are three types. We have igneous, that is from the inside of the earth, that comes from either magma or lava, molten rock, depending on how quick, and we'll come back and talk about them in depth. Well, not really today. Today is the process, how they change from one to another. We'll come back more in depth next week and then really in depth after Thanksgiving, because that's how are the continents formed, the motion of the plates, the creation of the Atlantic ridges, rifts, valleys, that kind of stuff. I don't know what I just did with my notes. Like I said, I'm very much building this class from the ground up, so I was definitely trying to do too much at once yesterday doing igneous rock. I have to do an intro to specifically igneous on Monday, and then we'll go in depth after Thanksgiving. I have 3 weeks to do all of that plus plate tectonics, not Pangea, and that's in 6 weeks. It's different. It's the changing surface of the earth and how it affects evolution and life, and that's in 4 to 6 weeks. I'm nowhere near there yet. I just know that's where it goes. Igneous is from the inside of the earth. It either cools very quickly, and it could be like pumice. Pumice is a rock that will float on water. It has lots of air pockets in it. I don't have any pumice. I bet you I do back there. Where are my igneous rocks?
I would like to see the rock.
Let me see this. Igneous rocks. Let me see if there's any in here. I have to use my field guide because these don't tell me what they are. I'm going to have to take one of these home with me, a set of each of these home with me, and identify them. This looks like pumice. Here, feel it. This is both. I'll let you feel them. Do I have obsidian? Yeah, pumice. They both came from completely and totally different. One has lots of that should float in water. I haven't.
That's what you
They're rocks, but I mean, the only problem is I don't want the little numbers on them to get wiped off. I don't know what to spray them with.
Well,
I know, but I don't know what to. Oh, I don't want people to see it. For a rock.
It's a little rock, just like you need to not be
Oh.
at all.
Metamorphic. Here, if you want to.
that's what's in.
If metamorphic is an igneous and a sedimentary that have been fused together. Where did this go?
How's it around that?
It's not bleach. It's not 100%. Anybody else want to see them?
It
I mean, they're both. Did you say you did?
Well, I've seen it before.
But
I've seen
but you never held them.
No, I have done that too.
Okay, I've never held them. They both come from lava that has cooled very, very, very quickly. Sorry, online. I can't pass it through the screen. We haven't invented that technology yet. I lost my cursor. Where did it go? Metamorphic happens inside, not like magma inside the earth, but with heat and pressure, and it takes igneous rocks and sedimentary and it morphs them into something else, like this guy. I just don't know all what's in there. No! These are mine. These are not the schools up here. The ones in the box are the schools. Sedimentary comes from dirt.
It's gonna make a
Compacted
good
dirt.
mine.
I think my batteries are going bad on my remote. Okay, so the rock cycle, and you have something similar to this down on the bottom. Yeah, I think my batteries are. Something similar to this on the bottom. And this is the processes that are used to change from one to another. Your molten earth will cool and crystallize to make an igneous. It goes up towards the surface and it starts to erode to become sediment. That compacts and makes sedimentary rocks because they're so inventive with their stuff here. Okay, guys, oh no, don't tell me you broke. Don't tell me you broke. No, I've had this thing for forever. Crap, it's expensive. Yes, because it has the mouse function. Shh, like $100.
Oh.
The school is not going to reimburse me for this. If I don't, there's a chance that the battery is, I think it's just working.
$100.
Yeah. It's because it has a mouse function on it. I could try to use, okay, I'm going to use my other remote. I can figure out where it went. All right, so anyways, as I'm trying to find myself, so igneous weathers turns into dirt. That compacts, it lithifies, turns into sedimentary. Inside the earth, not lava, but in heat and pressure and stress, they take sedimentary and igneous and it morphs it, literally morphs it into metamorphic rocks. Okay, while I'm trying to find my other remote, because this one's not. I don't know if this guy's charged. I have to hope and pray that it's just I have to see if there's some more early batteries somewhere, because these batteries may have been dead, but I just replaced it with. So I just don't have a mouse on this guy. And that's why I'm used to showing remote. We'll go back together since I can't point and them see me. We go back to James Hutton. We've talked about this guy before.
Well, you don't just got Bluetooth.
Just because I didn't buy one. I've had that. Why buy a new one when I have an extra spare one that works just fine? Where are those two rocks from? Go back there. Anybody else want to see the difference of both?
I want to see.
They're both lava rocks. Who said me?
Oh, this is.
Yeah. Very quickly cooling lava, and so it gets air pockets in it. There is some soap that has bits of pumice in it, like for mechanics to help get the oil and stuff off their hand. It's like an orange in color, and I don't know what it's called, but I know I've get it scratchy.
My friend's Jordan's gonna use.
So James Hutton, back in the 1800s. I'm gonna have to sit to present today. I'm so sorry, but my cursor won't work. He was the first one. He was the father of modern geology, and he was the first person to talk about the rock cycle. Now, he only knew about two parts. He didn't know about the inside radiation of the earth. He didn't know about that part. He knew about the weathering. He knew about the sun had stuff to do with this. He knew that the earth's gravitational pull through sedimentary formation. He just didn't know about the technology stuff because we didn't have the technology to understand it. We just didn't. What if I got more AAA? There's no way that is my very last AAA battery. Yeah, I mean, I can get some somewhere. It's not a big deal. It's just.
You know what I do when I can't find batteries?
What?
Not a TV.
You steal the batteries
That's
out
what I
of
mean. I
the.
get in trouble for it. Come on, I don't even know. You better use the TV. Big old TV. What the hell was that?
What's
phone
that?
not working? What?
Oh, I heard a boom.
Hold
Hold on, I'll take you in a second. I'm digging for batteries. I got everything under the sun. I've got batteries. I've got gun range ears. Oh. Nope. Has to be that's what batteries on that. All right, let me freeze this and check because it sounds like somebody either logged on or had a question. Yes, in the chat window. Oh, the chart, it's actually on your, yeah, I'll go back. It's actually the bottom thing that's on your, go back. That's on your canvas paper, your note skeleton. It's just not as in depth as this guy. It's the same thing though.
This is nice, bro. I got the eyes.
I swear. Okay. So it's a giant recycler. The Earth's rocks are constantly being changed from one into another. We can tell how old the rock is by doing radioisotope dating on it. There's a very, very small chance that it's going to be an original rock. Like there's pretty much no chance it's going to be original rock because that Mars-sized object slammed into our planet and then melted everything back up again. But they're technically, they're not just like poof into existence. They're changed chemically from one type to another, from the inside of our Earth. Did everybody that wanted to see those have a chance to see those rocks? Where do they run off to? I'm putting them back.
Yeah.
It's okay. I know these two. I don't know all the other ones. 15. Now, if it comes from the inside of the Earth, and we will come back and do these a lot. I can't get this to go back in the box. Back in the box, please. There it goes. If it comes from magma or lava, it's igneous. If it is weathered down in any way, shape, or form, and then that dirt has compacted, turned into rock called lithification, that's sedimentary. And if underground, okay, not in magma, but because of pressure, heat, as you go deeper into the earth, it gets warmer, stress, it takes the other two rocks and literally morphs it into something new called a metamorphic rock. And we have a bunch of those over here too. But like I said, there are no keys. Each of these is supposed to have a key in it to let you know which number is which. A lot of times, if the teacher's smart, they write it on the lid in marker. And then you can't lose the paper. But whoever originally purchased these did not do that. Because I don't know what this is. This has green in it, but I don't know every single one of my metamorphic rocks. A lot of them look very, very, very similar. This one's got shiny bits in it. So like I said, I literally get to look at rocks over Thanksgiving break and analyze them with my field guide and try to figure out which is which. No, I have to take street plates home with me. I got to take hydrochloric acid home with me. I got to take all different kinds of stuff home with me to figure it out. I'm not making the bomb. I'm testing rocks.
He's testing bombs.
No, not testing bombs on rocks. No, I am not.
She's testing rock bombs.
So, but they can all be changed back and forth. And it's that process of heat, it's the melting that is going to break the different elements apart again, separate them, and depending on what's present when it recools, is going to change it from one type of a rock into another. Color comes from specific elements that are present as it crystallizes. Certain elements produce certain colors. Some elements can produce different colors depending on what other elements are with them. This is, I didn't put this on your thing, but this is just showing you basically what's happening underneath our feet. You have an uplift, which I have to sit down because my cursor won't work. You have an uplift from inside the earth. We will talk about the oceanic ridges after Thanksgiving break. Creates these underwater volcanoes. That's how islands are made, by the way. And then your floor of the ocean, the oceanic lithosphere, is always denser than the continents, which is why we have continents. They're less dense and therefore they go up. The oceanic floor is heavier and it goes back down underneath and then gets turned back into more magma and starts the cycle all back over again. Yeah, it's just more dense. Yeah. So the oceanic lithosphere, the sphere of rock from the ocean, is more dense than the continental, the land sphere of rock. And the oceanic will always go underneath the continental and push it up. There's a reason why we have mountains and hills. Mountains aren't necessarily volcanoes. It could be a volcano that's probably extinct. Magma can come up. Once it pushes through, it's no longer magma. Once it pushes out, it becomes lava. That is what creates islands out in the middle of the ocean with Hawaii. I'm pretty sure it's just that one volcano that's still active. Kilauea, right? Isn't that the name of the volcano there?
Isn't that like the world's largest volcano?
That I'm not 100% sure. I don't think it's the tallest, no, but it's a very active one. But Kilauea, the Hawaiian one, I don't think it's the largest.
No.
Well, it's created all the other Hawaiian islands. Not directly over here. It's that Yellowstone super caldera that we're really worried about here. Huh?
I already said that's which one.
Which one is? Mauna Loa. What is that?
Fine.
The big island. I don't know all my volcanoes. Right, so this one is sort of like okay, yeah, that makes sense. The Earth is constantly recycling itself in one way, shape, or form, and it does it with everything. It does it with water, it does it with rocks, it does it with nitrogen. The Earth is constantly recycling its resources. Okay, so igneous, these are examples of igneous rocks. No, I don't know what all of them are. I'd have to go back and double check it. But if the rock, there's two major types, well, there's a lot of them, but there's two major branches of igneous rocks. You have the ones that come from magma. They form slowly. They're in the earth. There's where the heat is. And so they cool down slower, which means they're going to make much larger crystals. And they have all the pretty colors. Everybody thinks that gemstones come from the very center of the earth. No, it's not true. They can. Certain ones do. They don't all though. If it comes from lava, which is exposed to the air and then cools down very quickly, it could be glassy, like the obsidian. Right? It could be very light and airy, like the pumice. So those are the two that I was sort of passing around. The brownish one that was like very, very, very light. I'll have to get a cup of water and see if it floats in it. That is one that comes from, well, they both came from lava, but the one with the pumice, there was more air that was present when that cooled down. If the lava is just going down the surface of the volcano, that's the one that turns into obsidian. If it gets shot up into the air, like what you think of when it explodes, that turns into pumice. There are other types besides those two. Those are just the two that I have in that box. These are all sedimentary rocks. You have igneous rocks and metamorphic rocks that have weathered down to some type of erosion. It could be from water, it could be from wind, it could be from animals, it could be from all different kinds of stuff. It could be from plants. Plants will break down the rocks that they grow on and grow in. Over time, the dirt settles, it deposits, and then it lithifies, it turns into rock. And when we're talking about relative, the lower or deeper into the earth you go, the older that sedimentary level is. The further to the surface you go, the younger that sedimentary stuff is. Let me see if that rock fits. Well, we got it. You don't want to ruin that. Because those little stickers, I don't need extras of those. And so metamorphics, they're made from other rocks under intense heat and pressure. It morphs it into something new. Let's see if it works. Oh, wrong box. And those are all images of metamorphic rocks. No, this was innocent. Oh, tissue. So we got 5 steps in this process. And I think this is close to the end of these 5. Okay, the very first step. Now this is the original one that was done by Hutton in the 1800s. So the original rock started with molten earth. Okay, so this is going to be step 1. Doesn't have to be depending on your point of view, but the original process. The earth is literally going to vomit up its insides into some way, shape, or form. It could do it quickly, it could do it slowly. Okay, so it comes up, it was molten, it cools, turns into some type of igneous rock. Step 2, some type of erosion happens. Weathering, erosion, whatever you want to call it.
I can't remember, but there's this movie that's made about a volcano, and like it killed like everybody in a certain area with the ash and everything. And I can't remember.
Pompeii, you know about Pompeii.
Yeah.
I don't know the name of the movie that they made, but yeah, it had a pyroclastic flow. You can't escape a pyroclastic flow. You literally live at the foot of the volcano, and the ash didn't, well, it killed some of them. The gases killed most of them. They suffocated. They lay down. Okay, you die. You lay down. You die, and then here comes the ash, and it preserved them. It mummified them. But yeah, that's in Pompeii. Is where that happened. I can't. Mount Vesuvius. I think it's Vesuvius was the name of the volcano. Vesuvius, I believe is how it's spelled. I don't know. I'm not a history person, but I want to say it was. I think that's right. I may have spelled it wrong. So after we have weathering by multiple means, step 3, then that dirt, that sediment by gravity deposits. And then it lithifies, which is how it's turned into stone. Some teachers, they call it cementation, but the proper term is lithification. It doesn't turn it into cement. And when we did superposition, the younger layers tend to be on the top and the older layers tend to be on the bottom. Now, we do have things called overturning. If you have a massive enough seismic activity, it flips the chunk of rock upside down. I have not presented that to you. In fact, in a lot of the questions that I've used, it says that no overturning has occurred. That means that it hasn't been reversed. Not that it's hard, you just would have to be told that there was overturning, and then that means that the younger ones are on the bottom, and then the older ones are on the top. I'm not even trying to do that. You become an actual geologist, great, learn that in college.
Is that more
I don't know. Honestly, I don't know. Some volcanoes are very active and they're constantly belching out gases and smoke and lava. Some of them have gone extinct. Some of them that we thought were extinct had started having more activity. The Yellowstone one is extremely active. That's why there's so much, all the geysers and the mud pots and the hot springs and all the different pools.
I thought that's the one we don't want exploding.
Yeah, they really don't, because it's going to be Earth problems, like not just our area, like the entire planet kind of problems. All right, so the fifth step, the rock, whatever it is, type of rock, as it is exposed to, goes towards into the Earth, not to the center of the Earth, not into magma. And I don't know where I have this stuff. There it is. Jeez, glasses. Counters heat, pressure, stress. Literally takes the different rocks, melts them together. Don't think of magma, but alters them so that when they start to cool off, the chemical composition has changed into a different type of rock. Not magma and lava kind of heat.
It says that it's still active. It will not be the oldest rock living stars on
From Vesuvius?
Yeah.
Like I said, I haven't. I'm not a geologist. Yes.
It has roughly about 40,000 tons of sediment, and we wanted to including the large explosion eruption from 16,000.
Yeah, that's the one you were talking. Yes.
So I got anxious at one point and I looked up Yellowstone.
Uh-huh.
It said that scientists don't think that Yellowstone is actually that much of an issue because like the magma underneath is like extremely hot, but it's mostly solid. Or like the chances of it erupting are pretty good.
Well, it depends. It does depend. And we haven't done volcanoes yet. There is a section, a volcanic section later on. In if you will, the belly of a volcano. Not like it's cool down underneath. Depending on how hot it is going to depend on how dangerous it would be. And I have to go back, like there's different chemical compositions depending on the heat of the magma pool, if you will, that's underneath it. I do know though, if that thing really does decide to go haywire, it's gonna block out the sun for a long time. Yes.
I was looking at the same thing, but it says right here, 86 earthquakes are on U.S. National Park Center of eruption room.
You know how many earthquakes Yellowstone has in a day? You can't feel most of them. I didn't feel any when I was there. It's extremely active. All right, so this is the one that you guys have. Yes, a different type of rock can sort of jump from one to another, but in general, you have your molten earth. As it cools, it crystallizes, forms igneous. That's going to weather, erode, and it's going to turn into dirt. The dirt then settles and lithifies, and that turns into sedimentary rock. Then it's going to go through metamorphosis, not in magma, but just as it gets buried, layer upon layer after layer, as it becomes buried, it'll metamorphosize. And as that becomes deeper and deeper and deeper, then it will eventually melt and the whole process will start back over again. Yes, there are ways where you can go back and forth. But that is the original rock cycle that was done towards the latter part of the 1800s. Okay, so just as a overview, minerals can be found in all three. They don't all come from the inside of the earth. Some do. The igneous has two major types. We will get into this. It could be granitic, like granite. It could be basaltic or basalt. Sedimentary, this is the only place where we find fossils. This comes from dirt, layers of dirt. Metamorphic. Hello? Oh, yeah, give me just a second. Let me freeze my screen so I don't see you. Okay. I don't know why they changed it. We're supposed to take attendance within the first like 30 minutes of class. And that was them telling me I needed to take my roll. All right, let me double check online. Where did I say the chart was in Canvas? On the notes, it's like it was the previous slide. It just wasn't as in depth as the other one. All right, so